Hello, this is Raf Alvarado and welcome to Exploratory Text Analytics. In this video we're going to look at TFIDF, which stands for Term Frequency Inverse Document Frequency. Term frequency inverse document frequency is a measure of term significance. So looking back at the graph that we saw earlier produced by Loon back in 1958, which sort of sets the table for what we're trying to do here. Remember, the goal is to somehow discover that something that approximates the curve that we see in the dotted line, the curve that would describe or explain the resolving power of significant words. We saw that the term rank, the zip constant didn't quite do that. It has a shape similar to that, but it, as it were, peaks too early and includes a lot of words that are not really significant in our view. These are stop words and so forth. And so we're looking for a curve that's a little bit more, where the mean is a little bit further to the right. We've seen, that term frequencies are not always the best indicator for term significance in a document. As I've just mentioned, stop words and common words are frequent, but they're not indicative of a specific theme or topic. So one common way to resolve this problem is to weight the terms in the document by multiplying their frequencies by the inverse of their frequency in the document corpus as a whole. And this measure is called term frequency inverse document frequency. So we're going to explore what that means. So one way to calculate term frequency inverse document frequency, this is probably the most common formula, and we're going to show later that there are lots of variations on this. But coming up for a score, a weight measure for the significance of a word in a document can be accomplished in this particular way. First of all, you get the number of occurrences of the term in the document itself. So if the document might be a chapter in a novel, count how many times a particular word exists in that novel. This TF is here listed as just the number of occurrences, but oftentimes it's represented as a probability, in other words, as a relative frequency, where you divide the total number of terms, you divide the word by the total number of words in the particular document, and there are other measures as well, which we'll look at. And you take that and you multiply it by the logarithm, typically it's base 10 by convention, of the ratio of the total number of documents. So for example, if your corpus is divided up into paragraphs or chapters, you want the total number of paragraphs or chapters. And then you want to divide that by the number of paragraphs or chapters or whatever unit you're using, the number of those that contain the word at least once. So the document frequency and the term frequency are a little bit different in the sense that the document frequency is only counting words once, and the term frequency is counting words as many times as they appear in the document. Although there is a term frequency measure that's simply binary. You get a 1 if a word exists at all and a 0 if it doesn't exist, and we'll see that. But this is the essential formula. As you can see, it's pretty simple, and we're going to look in our this week in our notebook how to compute this on the corpus that we're working with. Very quickly, just looking at the variations, and there are more than these. If you look at the scikit-learn documentation for how they compute TFIDF, you'll see even a different measure. But this is just to give you a sense of the number of the varieties of different measures for both the TF term and the IDF term in that formula. So you can see that there are 6 variants of TF here, and there are 5 variants of IDF, so that gives you 30 possible formulae. So you can see it can get pretty complicated kind of quickly if you worry too much about this. We're going to basically focus on the simple methods. The ones that I prefer are the term frequency measure, where you just divide the number of terms that appear, a particular term appears, divided by how many terms there are in a document, or dividing the number of times the term appears by the total number of times the maximum term appears in that document. That is effective as well, and it's also much faster to compute. Regarding IDF, I tend to stick with the inverse document frequency measure there, the second one, but sometimes it's useful to use a smoothing function, such as the third and fourth. And it's something actually I encourage you to look at and play with in the notebook. So what's the use of TFIDF? So TFIDF was originally designed to solve a problem in information retrieval, which is to rank the results of a query. So if you search for a word in a text database, a document database, and you get back a bunch of results, you don't want to sort them purely on the basis of how many times your search term appears in that document, because that's not always a good indicator of its relevance to that document. So that's why TF-IDF was created. And mathematically, it fits into what we've already seen in terms of how we talk about the probability of a sentence. So you can think of TF-IDF as a kind of language model, and the query that you're sending to retrieve your document as a kind of sentence. And what you do is you get the document that produces the highest probability for your sentence. Pretty nifty trick. But TF-IDF can also be used for other things. So it can be used for, for feature extraction. You can take the sum of TF-IDF in a document, like how much significance does this document contain, as it were. You can flip it and talk about the sum of TF-IDF values for a particular word, and so you can rank words in a language model. You can also perform dimensionality reduction. So we're going to look at this too. When you create a corpus and you have, say, 40,000 terms, which is close to what we have in our corpus, that's a lot when you start to create a vector space model of it and you want to do certain kinds of operations. You want to reduce that by at least an order of magnitude, and you can do that fairly neatly with a TF-IDF measure and take simply those words that are significant, very much like the cutoff lines that we saw in Loon's diagram at the beginning. And you can also use it for content analysis, which is a rudimentary way of doing what we're interested in doing in this course, which is the exploratory part of the cultural analytics part, which is to say, wow, what words are significant in this particular corpus, or what words are significant in this particular novel. You can get a kind of reduced representation of a text and a kind of summarization of the text through this technique. So in terms of how TF-IDF fits into our data model, I just want to point out a couple of things. Keep in mind that TF-IDF, because it was designed originally to talk about the significance of a term in a document, is a per document term measure. So the results that you get from a TF-IDF analysis can be mapped onto the doc table in the data model that we talked about last week. So remember, the doc table consists of your discursive units, the ordered hierarchy of content objects that you're using to chunk your corpus into, say a bunch of paragraphs or a bunch of chapters. So when you get your TF-IDF measure, you can just add a column to that table that then grows your model. You can also, if you apply summary statistics, as we mentioned in the previous slide, we can talk about TF-IDF associated with each term in the vocabulary table. So each term could have a feature, maximum TF-IDF, mean TF-IDF, and the sum of all TF-IDFs. And you can then distinguish words or terms in your vocabulary table that way. Finally, it also helps with developing the language model for a corpus. So that's one of the reasons why you would add it to the table, the vocabulary table, because you can then start combining and comparing TF-IDF with other features in the vocabulary table, such as term probability. So a quick look at some examples from our corpus. Here we're looking at the corpus, the tokens, or actually the terms in the corpus, sorted by their term rank. You can see that's sort of the middle column there. So term rank is what we talked about when we learned about Zipf's law. I've also included something called part of speech max, and that is, even though terms per se don't have a part of speech, that's a property that applies to tokens, terms nevertheless have most frequently applied parts of speech, and actually some terms only have one part of speech applied to them ever. So it does make sense to transfer the statistical distribution of a part of speech from the tokens table into the terms table. And that's what I've done here. So the is most frequently, and I think only ever classified as DT, determinative, and you can see the others as well. Natural down there in the middle, as it were, is an adjective. So this table shows the distribution, the relationships between certain measures. You can see that N and term rank are inversely related, so that as term rank increases, or actually it should be as N decreases, term rank increases. You can also see Zipf's constant, which is an attempt to come up with that middle dotted curve that we talked about. And you can see that it does have a distribution that's in the middle, skewed more toward the N side than to the term rank side. But there are two other measures here that I want you to look at, which is how what I did with the TFIDF measure from this corpus, which we're going to look at how to derive. You can see that if you take the sum on the right of TFIDF's 4 words, you end up with an interesting distribution which clumps more in the middle. You can see that the darker green measures of the TF-IDF sum are oriented toward words that are not stop words, but words that look kind of interesting, like navy, natural, strange, voice. We can imagine that words such as these would be more discriminative, that they would apply to paragraphs or chapters that are talking about something in particular, that would make that relevant to single out. Here's a distribution that I think is kind of interesting of showing this TF-IDF summary versus term rank. And here we see how this measure might be a candidate for that significance curve that we're looking for. And what I've done here also, just as a bonus, because I think it's interesting, is I've colored the dots in this visualization based on the part of speech. So each dot is a word, and it's basically showing you its rank versus its sum, but also what part of speech it is. And you'll notice something interesting, which is that a lot of the proper nouns kind of drop out, as it were. So it looks like it's almost raining proper nouns. And so this looks like an interesting way that we might be able to actually statistically separate out parts of speech, which I think is interesting. I'm not sure if there's been a lot of research on this. I'm sure there has, but I'm not familiar with it. It's not covered in the text that we're using in this course. But I point this out to you just to pique your interest. Now I'm going to take the same curve and do the represent the axes logarithmically. So then we actually end up with a kind of a hump that's interesting to us. And what this hump shows, if you could hover over each of the dots, which you can do in the Jupyter Notebook, you'll see the words appear. And the words on the left, the more sparse words, are all stop words. They have a low rank. That means that they are extremely frequent in the document. And as you move to the right into the apex of the curve, you start to hit interesting words that are significant both statistically and intuitively when you actually look at them. And as you go to the right, the words are still interesting, but they start to become less frequent. And so what happens is that we can use a chart like this to come up with a way of partitioning out significant words that we can then use for the purposes I described earlier, such as dimensionality reduction. So in this case, we might define a lower bound for term rank and a lower bound for TF-IDF sum, and apply those two constraints to our data frame and end up with a small set of words that we can consider to be useful for our analytic tasks.